Okay, so I'd like to welcome everyone here to Clyde Road today to the Energy and Environment Division's second webcast and event of the year so far. You're all very welcome. Again, that's to everybody here and everybody dialing in on the webcast. For those here in Clyde Road, I'd like to draw your attention to our two emergency exits. If you can put your phones to silent, and I think we all signed in on the way in. So again, just very quickly for those here for the first time or those dialing in for the first time, the Energy Environment Division hosts 7 monthly lectures during the year. This is our second, so typically on the first Wednesday of the month. And I suppose over the next coming 6 months or so, we'll be running a number of breakfast briefings and seminars and other lecture events. So I suppose just look out for advertisements on that. Tonight's presentation is titled The Smart Home Technology Trial and Demand Side Management, and will be co-presented by David Phelan from Electric Ireland and Daniel Dixon from EirGrid. So David is an engineering graduate who holds a master's degree in energy systems from UCD. He's a chartered engineer with 10 years experience in delivering and project managing a range of energy and innovation related projects at international, European and national level. Within Electric Ireland, he is responsible for delivery of a range of innovation projects and contributes to development of Electric Ireland's solar, PV storage and electrification of heat programs. Daniel is a senior engineer within EirGrid. He graduated from DIT and joined EirGrid in 2014. He has worked across various departments within the EirGrid group, gaining technical skills and experience across a number of roles. He's currently part of the EirGrid innovation team, working to create flexibility in the system to adapt to the needs of an ever-changing electricity industry. So before Daniel is going to kick off the first presentation, for those joining on webcast, if you have any questions towards the end of the session, again, we'll have some questions at the end. If you want to email your questions to engineerswebcast, all one word, at gmail.com. That's engineerswebcast@gmail.com, and we'll be reading your emails if you have any questions. So without further ado, I'll hand over to the guys.
Thanks very much, and thanks very much for joining us this evening. My name is Daniel Dixon. As John said, I'm one of the engineers within the innovation team of EirGrid. So EirGrid, for those of you who are unaware, are the transmission system operator for the Irish transmission system. We're also the market operator for the single electricity market. So today I'm just going to give you an overview of the driving factors behind developing Power Off and Save. As it says here, Power Off and Save is a residential demand reduction project that we've developed. The main aim of the project is to investigate the capability of household consumers to reduce their electricity consumption at a request of the transmission system operator for a set period of time. So really, why are EirGrid interested in how residential customers are now using their electricity? Well, over the last 20 years, we've started to see our power system have fundamental changes in the technology that makes it up. We've seen wind generation rise to over 3,500 megawatts on the islands. We've seen the emergence of solar PV in both Ireland and Northern Ireland. We've also seen the large-scale deployment of demand-side management at an industrial level. We've seen our installation of our first battery storage facility in Northern Ireland. And finally, I suppose the last link or missing link in this evolution is customer participation. And this is really the rollout of smart home technologies and the adaptation and how quickly they're going to be picked up. I suppose 10 years ago, nobody had a smartphone or an iPhone, but they do now, and they use it day to day, day in, day out. And there's also the potential for electrical vehicle rollout as well. So Power Off and Save really looks to combine both demand side management and smart home technology. And just to kind of take you back in terms of what is demand side management and its evolution in Ireland over the last number of years. So demand side management involves electricity users having the capability to change their consumption from normal at a request of the transmission system operator, generally for a set period of time. At the moment, this is typically done by industrial users, reducing off non-essential equipment such as chillers, pumps, refrigeration units. So in terms of system benefits and from a TSO point of view, this offers greater accommodation of wind and other renewable sources, and it also provides greater flexibility on the system. In terms of customer benefits, it also has the potential to reduce electricity bills. So just to give you an idea of the evolution of demand-side management in Ireland and its growth, in 2012, demand-side management has moved from a time where there were a low number of demand sites or individual demand sites on the island, where now we've grown up to over 400 megawatts of installed capacity. And with this growth, we've also seen increased complexity. So with this, like, to understand the vision, I suppose, for demand-side management moving into the home, you only really have to look at the multinationals that are invested in smart home technology, such as your Nest, your Climote, Amazon Alexis, even Electric Ireland are now starting to trial smart home technology trials. And secondly, looking at both national and European future energy policies, demand-side management will play a key component in the successful evolution of the power system. So with this in mind, EirGrid began trialling residential services to encourage technology and innovation in the sector. We ran an industry-wide competition in which Electric Ireland were awarded a tender to deliver the programme. We launched Power Off and Save in June of 2016, and we've had a number of key learnings and highlights to date, which David will take you through in more detail. And most recently, as a highlight of the project, we've now been shortlisted for the Engineers Ireland Technical Innovation of the Year Award. So I'd like to pass you over to David now, who will give you a more detailed run through the project, some of the key learnings in terms of customers, how they've perceived the project and how it's been taken. So without further ado.
Thanks, Daniel. So just to recap in terms of the Power Off and Save project, essentially it is just where EirGrid send a signal to Electric Ireland then send a signal to the customer, and the customer then reacts in some sort of way to reduce the consumption and turn off appliances where possible in the home without affecting the comfort of their home. And what Electric Ireland do then in return then is they incentivise the customer for doing so, and what we're incentivising them with is about €10 per event. An event lasts roughly about 30 minutes. And over the course of the whole project of 18 months, we're hoping to have about 10 events. Currently, right now, we've had 6 events so far, so we're halfway through the whole process. And I'll go through some of the slides. I think I have about 20 slides to go through, but I can go through some of them very fast and some of them slow. And we'll have questions at the end that I'll be able to facilitate as well. But just to give you a flavour of who Electric Ireland are, and at a glance, we've 1.1 million customers. We about 50% market share of the electricity side of things and about 20% of the gas side. We're a leader in the Irish market. We're a trusted brand, which is a strong thing that we look into, and we also have partnership experience with a number of technology providers. Examples there on the right with Honeywell, Nest, Climote, and in terms of this project, we've also partnered with Glen Dimplex and Accenture. So overall, this is the solution. It's quite a complex slide, but to simplify it down, if you look from the left to right and look at the verticals, EirGrid send a signal to Electric Ireland. Electric Ireland then send a signal then to a number of technologies within the homes, and then whatever those technologies are, homeowners can either manually switch them off or they can be automatically switched off. This data then is aggregated and collected, and we carry out customer research. I'll go through some of these technologies individually now. For example, we have a smarter home system, and we are looking to launch this in the new year. Basically what this is real-time metering capability for the homeowner. A sub-meter is put in on the mains incomer and also on the immersion. So the customer gets a gateway in the home which collects all the data and is sent up through the cloud and is put out then through an app then that the customer can use. We also give them smart plugs that they can switch on and off appliances within the home, and customers so far find this very useful. We've trialled this out with about 500 customers so far, and feedback is very positive. In terms of the metering capability, we have 5-minute data, and we have recently just got capability to have 5-second data, and it's providing a lot of learnings on this project as well. Just to give you some examples on the screenshots for the app, the customer sees in real time how much energy they're using in watts. They see a cost then per hour. They also have they can see what their immersion might be using and what the smart plug what it might be on. For example, it could be a washing machine or tumble dryer, dishwasher, etc. Also, the customer is given an estimated time when their bill will be posted in their letterbox. An estimated bill for them, and disaggregated data on what appliances are using, what their standby load, what their dishwasher is normally using, etc. And then what's also useful then is we can show historical usage throughout the day or the past yesterday or the past week. Some of the smart plugs, what we've looked at, and we carried out some research on this with IPSOS MRBI, who we've partnered with. Some of the typical appliances that customers use are lamps, kettles, televisions, washing machines, tumble dryers. They're the main ones. And in terms of installation, when we have partnered with Actavo, and just during the caveat here on this slide is, with the installation, we normally the customer or the installer normally puts a smart plug on the kettle, and then it's just an easy thing to switch on, just check and make sure everything is working okay. So some customers maybe might leave it on the kettle just to keep it to see what it's using and whatnot. This is another technology that we're using, and it's a Glendimplex quantum hot water cylinder. It's a smart cylinder that is highly insulated and gives a lot of information back to the customer. What we can do is then control the cylinder and switch it off then when we like. We'll also have capability later down the line to potentially switch it on, but it's nothing to do with this project. In terms of customers signed up for this, we have about 50. In terms of the installation, it's a long, tedious process. I might bring you through a slide later, but instead you have to go to a customer's home, carry out a hot press survey, and then go back again and then carry out an installation if they're so fit. This is another new technology. It's a retrofit solution for the sink bath on-off switch that is typically in the Irish home, and it's developed by Climote, who are an Irish company. And essentially, that sink bath switch is replaced by a hub, and it's a digitized timer then that the customer can put in their times any time during the day, and then also they see how much hot water they have in their cylinder. The customer is also given an app, and it's very useful, and it's just a very simple app that shows in terms of it's like a battery. You know, in this slide here it shows 30%. We have about 100 customers recruited for this. The installation is quite simple. You're talking about 2 or 3 hours, and it's very successful so far. So in terms of carrying out a power off and save event, we have about 1,400 customers recruited, and what we do is we don't give any heads up or notification to the customer, and we just say a power off and save event has started. Smart controls opted in will be turned off at this time. We ask you that you reduce electricity use for the next 30 minutes. And this actually text message went out on the 7th of February at 12:30 during the day. And then at 1 o'clock then another message went out, and essentially we're saying this, the power off and save event is over, and smart controls will be kept up, will be remained off for safety. So in terms of a push notification, some customers might have, if they have an app, they might get a push notification for that. The customer always has control to switch technologies back on, be it if it's from a smart plug or an immersion or whatnot. This slide represents just where our customers are. They were randomly selected. Some would have shown interest from various means when the project was launched, and could have emailed in. We have a smarter living program as well with about 4,000 customers that would have registered an interest in this. What I want to get through on this slide is that we haven't just focused on a cluster or anything like that. It's a dispersed population throughout the Republic of Ireland, and we have about 1,400 customers. Just in terms of recruitment for this type of project, it's quite complex. A lot of communications with the customer. As this is just a slide that represents some of the work that's involved. Initially, an email is sent out to get an interest, and we focus on a certain cohort. And as you can see, we looked at the smarter living customer base. We looked at people that have got energy efficiency incentives from Electric Ireland. We looked at people that registered an interest in the project. Then we also looked at night storage customers that would have been useful and quite good for the Glendimplex cylinder as well. Following that, then customers then fill out a 20-question survey, and you can see the big drop-off that you get from that. And there's a filter then on that. Are they suitable? Do they have broadband in the home? Some of these technologies, they need broadband in the home, or some the Climote immersion controller, for example, it uses a GSM, which is a SIM card. another example is after the hot press survey is carried out, maybe the hot press is not suitable, there's not enough electrical safety bonding there, or just the size of the hot press just doesn't facilitate the Glen-Diplex cylinder. And going through that again, then the customer has to agree to the terms and conditions of the project. And once they do that, then the installation is carried out. In terms of the data, we've engaged with Baringa consultants, and we looked at how do we report on the data to EirGrid, and we looked at two ways really in doing this. So first of all, we have a trial group, and whatever way they react, and then the way we look at the data then is we look at their historical data over a 5-week period, just the 5 weeks before the event, on that day, whenever it happened. So an event could happen at any day in the week, at any time, and what we want to do is test the appetite then from the customers. This particular event happened at 6:30 in the evening. I think it was around February, and we can see that in the top graph in blue, the trial group, you can see it reduced then for the half hour, and there was a 14% reduction of about 151 kilowatts overall as a demand response reduction. If you look at the below graph, we trialed it. We have a control group from the Smart Pays Go prepay customers. We have a 10,000 base of customers there who do not get any notification, so they're not in any way biased towards the project, and we see there's an 18% reduction there of 205 kilowatts. The next thing is in terms of system services and possibilities in terms of these technologies. And what we want to look at is fast frequency response and primary operating reserves. How quickly can a customer switch off technologies? And the more automated we get these technologies, the better, and there's an incentive there from EirGrid as well. So what we've put together in this slide is to show what the potential is in terms of the smarter home, the Glen-Diplex cylinder, the climate immersion controller. We also have the Smart Pay-As-You-Go group, which is on Group D there on that column, and they have 30-minute data, which is potential to 15-minute data. So that's why we looked at just replacement reserve in that slide. We also have 10 electric vehicles actually recruited on this, and we can switch them off if the customer has opted in for automatic switch off. Looking at the data then for the past 6 events, we looked at when does a customer actually first reduced or make any reduction in their consumption in the home, and typically there's a correlation there at 30 to 40%. We see 35% of the cohort would reduce their consumption, and then there's about 30 to 45% that do not react at all. So in the summer there, we carried out a questionnaire and a survey with the customers. We had 1,345 customers and 595 responded, which is a 44% response rate, which is in line with what IPSOS would have expected. And there was some interesting learnings on this. Some of the highlights that I want to put together in the slides here, what IPSOS and what the customers have said to IPSOS is that provided respondents are at home at the time and are aware of a notification, participation in power off and save events tends to be strong, and clear willingness to participate in the event. Actually, I just want to point out, IPSOS carried out this survey just after 2 weekend events. So it was probably, weekend events were not great in terms of the response because people are not engaged or they're not in the home or whatnot. There's an openness to more frequent, longer duration events and them taking place at peak periods. And there's actually a satisfaction and NPS scores for the Power Off and Save project are generally positive. The NPS is a net promoter score, and it's a rating in terms of how well and open a customer is to a certain technology or service. In terms of participation throughout the household, the customers are happy to participate once they're at home. And some of the learnings we've got back here is over half of the participants, generally 18 to 34-year-olds, participated in the previous 2 events, with lower participation in both events amongst the older cohort. There is evidence of several household members participating in events, including children. The TV, kettle and phone chargers are all popular items to power off. The main reason for non-participation is that the individual was not at home at the time of the event. Other than that, not noticing the text or having nothing to switch off were also cited, but there is no evidence of any strong resistance to participation, so this is positive enough. Some of the key learnings again on the data, just to recap. Over 40% of participants are reacting within 5 minutes of a text message. 30% are not reacting over the 30-minute period at all. Over 50% reduced their electricity usage for the 30 minutes of the event when compared to the half hour before each event. And this is similar to most of the events we've seen so far. And again, stressing the time of the day. We've had events in the evenings at winter time, during the day, at the weekends. We've yet to test out maybe a nighttime event, and we also want to test out more automated technology on this project. Just in terms of the issues and risks of the deployed technologies, I stated earlier, some of the homes that they need to be suitable for these technologies. They need to have broadband for certain technologies, or again, the hot press needs to be suitable size. One key learning for us especially was that customers were actually maybe overreacting and switching off everything in the home and switched off the broadband as well, which we lost data then, and it's a learning for us, and we communicated that quite early from the first couple of events. Just in terms of the participants, it's a positive reaction to the concept of residential demand response. Bearing in mind this is the first time this has been carried out in Ireland, especially with a company like ourselves and EirGrid. Our participant recruitment campaign has been completed, and in terms of the educational piece, as you're aware, the project can be quite complex enough, and then with the technologies then to explain how they work and whatnot. And sometimes with any technology, especially with IT as well, there can be bugs in the system, and these things have to be ironed out quite quickly as well. In terms of the project itself, some of the benefits and learnings we're seeing, from a policy perspective, it's good for national and European energy efficiency targets. From a power system perspective, it can facilitate intermittent renewables like wind and solar PV, and it can increase generation adequacy as well. In terms of the residential consumer perspective, they're seeing lower bills. They're also seeing first-hand technologies that are been deployed and trialled, so they're early adopters in that sense. And then in terms of the learnings and outcomes for us, we're seeing the customer journey, what's working well, what we could do better, how the technologies are working, what's the data like, and is there a market for this type of project in residential demand response going forward. So far, phase 1 has now been completed. Most of the events to date have been manually switching off. We've implemented most technologies on a phase basis. We're nearly at the automated phase, and this is where we introduce the more, I suppose, immersion technologies and hot water technologies, and can switch them off then when we like, I suppose. Another part of the project is what we want to do is test potentially a separate cohort of solar PV customers. We have a small number of customers that are on trial that have solar panels in the home, and what we want to do is test would a customer switch off the solar panels at an isolation switch beside the distribution board, and what's the behaviour towards that, or are they willing to do that? And it's something we're testing at the moment in terms of the appetite and whether it's possible technically as well. That's all. That's everything. I just want to say thank you to everyone that turned up tonight. I hope you enjoyed a few of the slides there. I'm sure there'll be a few questions that I might be able to provide more information on as well.
Thanks, guys. It's an excellent presentation. We have a couple of microphones we might pass around. Just if I could just kick off the Q&A. So again, what's the roadmap on this project? So you said kind of the second stage is maybe move to a bit more automated, but ultimately, what's the ideal output, or what are you trying to get from it that to interact with the, I suppose, existing consumers and
Yeah, I'll go first. Thanks, Dave. Yeah, I suppose really at the start of the project, it's really to see the adaptation and how are consumers willing to switch off and adapt to electricity suppliers managing their electricity supply in the home rather than having their own control. And if we can move to a stage where the customer is not affected by us doing this, how is it that it moves on and moves forward? I suppose in the long term, it's very early stages in terms of this project and what the overall potential is, but if we could move demand side management into residential, we could see capability of reducing like larger load on the system and the demand. So that's probably where we'll probably look to move. But again, it's probably very in the early stages.
Yeah, just to add to that, it's testing the customer appetite to the technologies that have been rolled out. So like some of the technologies there that I've mentioned, they're quite difficult to actually roll out and implement. And also we have the prepay meters in terms of the smart pay-to-go meters, and they've got 30-minute data. If we can get better data from that'll be a better learning, and just we've got more technologies that can facilitate residential demand response. This project is it's the first of its kind been implemented in Ireland. So we wanted the outcome really, is it going to be successful? Do the customers want to be involved? Is the incentive good enough? And all these things have been tested, and there's a lot of learnings to get from it.
Hi, Carl Purcell from the Sustainable Energy Authority of Ireland, Programme Manager, the Behavioural Economics Unit there. Really interesting work. It's really good to see that things like this are being trialled as well. So I just have a couple of questions. You mentioned earlier that people are randomly assigned in. So it is a fully randomised control trial in that sense, is it? And
yeah, so there's a slide there I put up. We have a smarter living customer base of about 4,000 customers that would have registered an interest to Electric Ireland to test out various technologies. Then we went to another cohort of maybe energy efficiency customers that would have got credits on their bill if they implemented any kind of energy efficiency measure. We have that, and if they're open to marketing, we would test them. When we launched the project, we got about 500 emails in from various different backgrounds. Could be from academia, just people just within the industry that just want to test these new technologies.
And then, sorry, I won't take up too much of your time. I just had a couple other questions. Have you looked to see if there's any rebound effects from afterwards? So fair enough, they switch off for the 30-minute period, but then is there a huge spike in use afterwards or throughout the day, or is there like a moral licensing effect where they turn it off and then over the next couple of days you see them actually using more energy than they typically would on their typical profile?
I think this slide probably depicts it. Like, so this event was at 6:30. You can see in the kind of yellow grade or yellow kind of area, and then at 7 o'clock, then you can see, and in both the blue lines, they're the trial group. They both increase slightly. So there is a slight rebound effect. Customers maybe go to the shop for that half hour, or they just switch off whatever they can in the home. Some parents, they play games. Let's turn off the laptops, the PlayStations, the TVs, and then everything comes back on. Then as maybe a reward for just doing their bit.
I think we've also seen that within the trial, users who are becoming more energy efficient. So when we do call a demand response event, they actually have less demand to reduce, so therefore they can't participate as much. So they're actually becoming more energy efficient within the home.
Yeah, and this is the last one, I promise. Have you thought about tailoring the event times to the individual? So doing some sort of load curve segmentation, looking at people's usage normally, and then targeting the event times actually based on the individual rather than, say, kind of on a mass group?
Kind of. What we've looked at maybe is some predictive analytics based on what their schedules are for maybe when they want the hot water. Want to see when's the peak times for electricity demand, and then can we shift that demand to maybe a different time period. That's one of the key criteria for us in terms of an outcome. Can we do that, and is there an appetite to take part in it?
Very good.
just a quick one, and in terms of Paul Martin from SCI as well. Just in terms of the curtailment of wind and things like that, have you thought about texting people and say, turn on your storage heater, etc., etc. Now it's cheaper with wind.
I think, Paul, that probably feeds into the roadmap. This project is just about switching off load, but maybe Danny, further down the line.
I suppose it's what DSM allows for more flexibility, and by shifting demand at that stage, and the demand is moved to later at night when there's more wind available, it therefore allows for less curtailment, is essentially, I think, what you're looking at in that way. But it's not an area that we've investigated in this project really in detail.
Separately in this project, as Dan just alluded to, it's about switching off load, but with these technologies we're building in the capability to maybe switch them on, and that definitely will curtailment could be a promising area to investigate down the line.
Liam Tolton is my name, from the Energy and Environment Group. I think, just to build on the question the second last speaker or questioner asked, I think this curve is very interesting, because in both of those cases there was a small rebound effect, but the blue was lower historically right out to 4 hours afterwards. And that kind of suggests to me that maybe they went around the house, looked at it, they could switch it off, and they either forgot to switch it back on again, or they didn't need to switch it back on. And I presume you guys have gathered all of this information from all these events, and I think it would certainly be worth looking at the much longer term response after each of the events to see, was it that level of action that either people forgot or realised, God, I didn't need that on in the first instance. Because obviously you can even see in the lead up to both cases, the trial group was actually using more than the historical pre-event action. So I think there's probably more in the statistics there that you can dig into to look at the much longer term events, because if you have the data, you don't need to run the events again. You can go back and look at that data. But I think overall it's very interesting work, and I think it's when you get to the part where you start to automate it, the real question it will beg then is, well, actually, do you give the people the option for the automation to turn it back on again? Say, by the way, will we turn back on your immersion, or do you want to wait for another couple of hours or something like that? Might be a really good use of the automation in the future. But yeah, it's certainly very interesting work. Yeah. So it was more an observation than a question, but I think it's interesting.
It was a very good observation, and just from memory on the focus groups before the project started, I remember we just asked the question, what's available to switch off in the home, and just one guy I remember saying he has to go upstairs and switch off the lights, and that's probably the example just that comes to mind. When you go up into that spare room, just you keep everything off then, or whatnot. Just in terms, I
suppose the education piece that I would be suggesting as well is that try to focus them on turning off the big hitters.
Yeah.
Don't have them turning off their phone charger. That's not going to make any sense. Have them turn off their electric kettle maybe for 5 minutes. Get them to turn off the tumble dryer and the immersion and the dishwasher, those kind of things.
We try to communicate that as much as possible without overdoing it as well.
It's really interesting work, and well done.
Yeah, thank you.
I think I'm next. John McGowan. I'm essentially, for the purposes of this discussion, retired, so you're safe. I think it's a very, very good presentation. You get the sense that this is the beginning of something that is going to grow into something far more sophisticated than you can even imagine at the moment. But just to help me with some information, 3 questions. One, what is a typical duration, we'd say, of the SAG, or of the power reduction period that you need? Secondly, I think you had it on the slides, but I wasn't able to read it quickly enough. What are the typical big hitters, in power usage in a home? And thirdly, a more difficult one. I'm aware from being involved in lectures in America that the whole question about privacy with smart metering, the fact that in theory you actually know when people are at home and they're not, actually is something that has caused a problem. Have you been able to garner any learnings from others who have been attempting systems like this that can help you to avoid that problem?
ask you to repeat the first
Oh,
question.
the first question is
I remember
just.
your name, John.
I'm sorry, but it's just such a great opportunity, David.
Yeah.
I can't let it go. The first one was a typical duration of that you want a peak reduction over.
So each demand response or power off and save
Yes.
is about 30 minutes.
30 minutes. Yes.
And then just to give you a flavour for some of the data, we're getting 200 watts reduction from most of the manual customers. That was the peak that we've got
Yes.
in terms of the mean reduction, 200 watts per home. The lowest we got, say, at 12 o'clock during a weekday was about 50 watts per home. Your second question then?
The second one was, if you would Pareto, what typically are the biggest power uses?
Yeah, so the immersion is the big one in the home. It's
Even with gas heating as well.
Yeah. So if most homes that have oil or gas heating may have an immersion, the bath switch on immersion is about 3 kilowatts. The sink switch is about 2 kilowatts. Then you have maybe the washing machine, tumble dryer, dishwashers. You're talking between 200 watts to 500 watts.
Sure.
What we're targeting is appliances that do not affect the comfort of the home really, and so like there's the simple, easy, I suppose, ones to get in terms of the lights and the laptops and the chargers. They're very, very small, but if at least the customer feels like they're doing something, and then we can start getting them to more of the bigger hitters then as well.
Sure, and the final question is the one about, let's call it privacy and data protection derived from, the information that you're collecting on usages in homes.
So each customer then, we let Ireland store all the data, and in terms of the privacy, then we don't transfer it only to EirGrid, and it's anonymized data then as well.
David Sutton from Grant Thornton. Just to echo John's comments, it's a truly pilot project. We hear a lot of pilots, but this is a proper innovative pilot project. Well done. My question is, it's similar actually, but it's international comparisons. Like, how does the Irish response, is there kind of other international pilot projects, and how does the Irish consumer kind of react relative to other consumers? Is there any international comparisons?
It's a good question. There's a market over in France, and a crowd called Voteless carried this out, but they focus on more air conditioning and switching off that automatically. I think the load is, you're talking maybe 500 to 1,000 watts. A crowd in Switzerland called Tico also carry out something similar in this space as well. Again, it depends on that area as well. I think it's on air conditioning too. Is there anything else that comes to mind?
There's also an eco-watt scheme in France, but that's related to in Britain. They've rolled out kind of a more energy efficiency process that they alert people to when there's capacity issues on the grid, that kind of area. But now, in terms of the likes of Australia and America, we haven't really looked, but we think they do have capability for this kind of area.
Hi. Hello, good evening. My name is Donald Finn from UCD. One issue you mentioned is that the trial customers, they had an option of opting out. Yeah. So I guess that's in the context where they said, I've done this once or twice and I'm not happy with it for whatever reason. Yeah. Was there any evidence of customers opting out from the program?
Which?
The opt-out is from the program itself or from opting out from an automatic switch off?
Well, in the context that, if I remember right, you said that when a customer is called, they can actually opt out of participation.
Yeah,
so was there any evidence of opting out by customers?
Not specifically in terms of when the power off and save event happens, a customer can they get the push notification in the app, and within the app they can see a power off and save event is happening, and then they can cancel that if they want. And actually, just in the last event, we definitely had one from the climate immersions as well. But in terms of opting out of the project altogether, customers, if they want, they can do that. If they change supplier, they can do that as well.
Hi, My name is Fabiano Palloneto from UCD. I'm one of the random selected customer that I got for phase 2 actually. And my point, I have 3 questions. The first of all is the identification of the baseline for phase 2. Because did you plan to have a period of time where the customer cannot interact with the system, just to understand the baseline? Because here, for the phase 1, you're considering 5 weeks prior to the first event, but for the phase 2, what is the baseline? Because there is a big discussion in the research community about the identification of the baseline.
Yeah, Fabio, to answer that question, it all depends on the time of the day and what day of the week it is. So if it's in the morning at 6 o'clock in the morning, you might have a lot of immersions been switched on at that stage. So that will be the baseline of maybe 2 kilowatts per home or 3 kilowatts per home. If it's at 12 o'clock in the day, you know, obviously it's a lower baseline and not much is on in the home typically. And seasons as well, yeah.
Okay.
Second question.
Second question is about you taking control of a tank of hot water.
Yeah.
From a safety perspective, have you considered to do 1 or 2 cycles for avoiding Legionella problems and all these things? Because I didn't see anything in the instruction about it.
Yeah, no, I didn't put it into the slides, but within the quantum, the Glen Diplex quantum hot water cylinder, I think once a week they have some sort of health function, which they heat the water above 65 degrees, which you know, mitigates that concern.
And also for the climate.
And the customer has a setting within the climate that they can set the temperature whenever they want, and that can mitigate that concern as well.
So third and last question is about the geographical location for the random selected customer.
Yeah.
My point is, you know, we are talking about a feeder level, so a transformer level. Yeah. Are you thinking to localize the events to certain area, or when EirGrid gives you a signal is for the overall Ireland, and are you planning to do for local area where there could be a strain in the power line?
It's a very good question. Not currently in this project. We've about another 5-6 months left of it, but potentially down the line there could be some collaboration with ESB networks where they could maybe zone in on a specific area that has a weak network, and we could maybe facilitate that in some way with different technologies, especially when it comes to the powering on stage and whatnot.
You're not allowed to ask me about any other lectures.
Sorry, I am being greedy. Two other questions. Have you worked with any behavior change experts? So anyone from kind of the behavioral economics literature or anything like that is the first question.
I'll just answer that straight away, no.
No? Okay. That's interesting. And then the other one was, is the data going to become available for academic study through some avenue, or?
Yeah, after the project, I'd imagine it would. At the moment, we're getting a lot of requests from academia, and what my straight answer is no, because we want to analyse the data, make sure it's 100% accurate what we're presenting. But I'd say after the project, there should be some avenues there.
Cool. We have published the progress report as well. So the first progress report that has been published, and it's online on the EirGrid website. So you can look at that for more information, and Power Office South does have its own landing page. And then there's 2 more further reports that will come to disseminate the learnings of the project overall. Yeah. So.
Okay, thanks everyone for your questions. Just in wrapping up, and again everybody online, there was no questions that came in on the email. So thanks everyone for showing up. Again, everyone online. Our next event will be the first Wednesday in December. I think it's the 6th of December. Professor Barry McMullen from the the Energy and Environment Division, and DCU will be presenting on negative emissions technology. So a really interesting lecture lined up. In addition, on the 6th, we're looking to host a breakfast briefing that morning, and again, we'll publicise details of that. It'll be kicking off around 8 o'clock on the morning of the 6th, and the topic will be electric vehicles and their technology. So before wrapping up tonight, again, I'd like to thank ZIPSI and ASHRAE and the Energy Institute also for co-hosting and co-presenting, co-publicising the event. So to conclude, I'd like to thank the two guys for a really interesting lecture. And again, it's one of these lectures, sometimes they'd be quite interesting from a technology perspective, but I think, as Dave alluded to as well, and as some of the guys alluded to, this is really something that's going to affect us all over the coming years, and it's a great opportunity, and I think that's something that everyone, majority of people will look to get stuck into and get involved in, so I wish you the best of luck in that. So yeah, in conclusion, thanks again for showing up, and thanks again for dialing in, and if we could all give the guys a round of applause for excellent.